Yeah. All right. All right. Thanks for coming to this training. So, uh, as you may hear, this training is gonna be divided in two parts. Today, we're gonna tackle the first half of it. This is gonna go over exploit development, and yeah, we're gonna divide it in two. The first half, we're gonna go through the tools, theory, and the basics of reverse engineering an application and trying to find the inputs for exploitation. And then the second part, that's gonna happen. We will share the recording. So the second part that's gonna happen next week at exactly at the same time. And again, it's gonna be recorded as well. So what's gonna happen next week is we're gonna go through some practical examples. So I will share with you what do you need in terms of lab. So the tools and the target. And some challenges that we will be able to, we should be able to work together. And during the week, I'm going to share with you some offline manuals and documents so you can go through those challenges prior that. And we are not planning to go today over every theory of buffer overflows, depth, memory protection techniques, and so on. So because there is no reason to go over that, because basically you can find that enough data over those topics in the internet. So, but what we should cover in an exploit development bootcamp is how to find the inputs, understand the logic of the applications, how to once you find an issue, how to go with that, and how to understand a program, and how to after you have a finding, or you get, for example, a buffer overflow of any type of injection or any type of because we are not going to cover only memory attacks. But if you find anything that you want to exploit and you want to write an exploit for it, then you should be able to understand the logic of the application, find the flaws, and then follow along. So it's not only just getting a specific an issue and then exploiting that issue per se. If you have read in the past books or manuals or blogs over exploit development, you might encounter that these will only cover the specific techniques, and they will only cover the basics of the debuggers or static analysis or the technique itself in an isolated environment, and how to use that in real specific cases, more or less, of course. But what I would like to cover here is how to approach an application, how to start looking for issues, not from a fuzzy perspective, but from the exploit development perspective. I'm going to cover some basics right now, and then we can go a little bit deeper into those. So first thing first, we're gonna just tackle a few, but I was thinking about it, and I was trying to digest what would be the best approach for it. And I think the best way of approaching it will be with a CrackMe. Understanding how a program works is way easier if you use CrackMes than if you just directly try to exploit an application as a whole, because applications will be more complex and more sophisticated, and will have more ground to cover. But in the case of CrackMes, they are specifically made, their applications made specific with to choose one intention, to choose one function, that is that a cracker will track the application per se. And these applications, as long as they go up into difficulty, they will also start using protections, memory protections, debugging protections, and so on. So I will show you how to go through an application with a CrackMe, and then I will show you how to approach a full application, but also a small one. So in that case, you will understand how we can apply what we learned from the CrackMe to the application itself. In this case, we're gonna go through a Java decompiler that is prone to a buffer overflow. It's just a stack-based buffer overflow from the 90s, but it's still I think it's still a good learning material. And then I will show you how to follow along after you find that the buffer overflow for you could have found this buffer overflow from this application using a fuzzer or just manual testing. But in any case, I want to show you how to approach it from a reversing perspective, from using a debugger. Alrighty then, so let's begin. This training, as I said, is gonna be recorded. So if you cannot follow along, don't go crazy. You will have the recording later on, and as long as this training gets updated, I will recommend you guys that if you want to follow this training now or later, just go ahead and go to at least this website. I already got these CrackMes from it, so just go and get these CrackMes. You don't have to use specifically these two, but you can use any. So let's just take this one. So this is just an example. And the program that I'm using now is called IDA. Yeah, so let's cover that first. So I'm using a debugger. It's called IDA or IDA. This one. So it's called IDA Pro. They have a commercial license. They also have a free license that you can use if you want to just try it. And they have a disassembler and a debugger. So we are gonna use it for both. We're gonna do some static analysis and also some reversing, and later on we will use the debugger. And as far as I know, there is here the different versions, but you can also get the free version. So you can get the demo version, but the free version will always do as well. The free version has a decompiler. You can use these formats, and so it will work for 86 and 64. That's enough for what we wanted to do. Or you can just use the demo as well. The free, you can just go ahead and download it, and then you can get it for the different operating systems. In this case, I'm using it on Linux, but you can also have it on Windows, Mac, or Mac ARM. There are others that you can use. Is Jydra. I don't know how it's pronounced, but it's also a decompiler that you can get. It's made from the NSA from America. You can get it from here, from Git. I've been using Jydra for, I think, since they released it to the public, the first version. So it's quite good. It's an awesome decompiler, and there is also a debugger nowadays that you can use. Back in the day when they just released it, there was no debugger, but now they do have it. It's not as good, the debugger, as of course as IDA, and I think it does have some issues, the debugger, but the compilation part of it is really good. And I mean, if you just want to use it for static analysis and exploit development from a static side of it, it will be a great tool to have. Moving on, there is also x64 debugger. Back in the day, there was this debugger, only DBG. and there's older version as well. But OLEDBG, I think you might hear it if you in the past you took OSCP or OSCE or any of those certifications from Offensive Security, or you were choosing to crack me's, debugging, and reversing. OLEDBG was quite popular. There is a x64 debugger that follows the same concept. It has the same sort of interface, as you can see here, than OLEDBG. And yeah, so it's improved. It is better. It's completely, as I say, open source. And yeah, and it's way better than in my point of view that OLEDBG is way newer, and you can use it on 64 or 32 as well. So there are plenty of options. Let me show you the last one. That is Radare. I think that's not the website, but this is it. Radare.re for reversing. And Radare is a debugger, but also I think also they do have some the compilation features. It's quite tricky to use. I used it in the past. I wasn't a fan of it. I mean, it is useful. You can do anything that I will show you on IDA or whatever you can do on x64 debugger or GDB as well. So you can do it, but surely it's way more complicated, and the interface is more or less like this. Can I show you the interface? Not. Yeah, well, the interface is not as graphical as it. There are some graphical interfaces that I tried in the past for Radare, so it will give you sort of a GUI. But yes, I mean, I think basically when you do reversing, you should be able to follow the flow of the program, because you are trying to reverse the flow of the program while you are learning the flow of the program. So the tool itself, it should be something that is easier for you to understand. And on the same lines of being complicated, you have GDB debugger. That's not the website, but still, we can have it. GDB is from the GNU project. So this debugger is meant to be used with source code. You can use it without source code, but it's meant to be used with source code. There are some cool plugins for GDB that every other exploit developer used back in the day, like 10 years ago, with GDB and Oli, for example, for Linux. You can find those plugins for GDB init and for OLEDBG. Those plugins are those plugins that allow you to create shellcodes, find fingerprints of in memory, search the memory, and so on. But of course, when we are talking about commercial tools like IDA, on IDA, you can just write your own plugins. You can write your own scripts. It supports Python. It supports sort of a C, and of course, it's way easier and to follow than choose the command line of GDB. Again, with GDB, there are some graphic arts interfaces that you can implement on, but I think you should make your own decisions. So for doing reversing, you do need a debugger, and you do need a way of static analyze the code or decompile if needed. But surely it's a matter of what you like the most and what you feel more comfortable with. All right. So in any case, the theory applies when you load a new file. All the files, and in this case, I'm gonna load a P portable executable. So in this case, I'm loading into this. I'm gonna static analyze this one using the decompiler of IDA. So first thing first, it will ask me, how do you want to load it? I will say I want to load all the resources. That's quite handy when you have to load your binary, because if you don't know what I meant when you do a crack me, because you don't know where you want to look at the stuff. So loading other sources will become handier. So everything there. Okay, and this is choose a crack me, and the crack me is to just give you. I'm gonna go through the basics of a P file. Uh, Remember that you have to look at it. What I'm gonna show you, not from the side of how crack me is solved, because I'm not trying to show you how to do a crack me. What I'm trying to show you is how to approach a program when you want to reverse engineer that program, with the of course with the objective of exploiting that program, using an issue that you found. At the end of it, we will use a memory corruption based on a buffer overflow, but the concept is the same. All right. So the program itself, when it loads, you will see that you have a text section in this case, and there is some flow that the program is gonna start and it's gonna run. You can see here that this debugger is already spitting out some code. The compiler is spitting out some code. This code is called assembly code. When the machine runs this code, that's gonna happen is that it's gonna start running these functions. In this case, these functions, these are called opcodes. And there are different types of opcodes and different types of platforms that it can run on. In this case, you have the opcodes for x64, and then of course the values that will follow for that. And you will see that you have variables that are set here, and there are some different dynamic variables, and also there are some interesting functions that will be called. In this case, they are interpreted by the decompiler, and the compiler has assigned a name to it, and these functions, they are being run using this call opcode. And if you want to learn more about the opcodes and what they do, you can of course go online, use your favorite browser, and then look for the opcodes. There are not as many as you think, and then you can understand how these opcodes work: subtraction, load a specific address, move, call, and so on. All right. So if you want to understand how a call works and how you give an argument to it, and then I think you can do it online. If depending on the compiler, it will have or it will not. Ghidra, Radare, and IDA, they do have comments for the opcodes that you can set. They should be there, auto comments. So that you can see now I have the comment for load effective address, logical AND, integer subtraction. This is a call procedure. So again, load effective address, and so on and so on and so on. Yeah. So that's a memory helper. So basically, if you don't remember what the opcode does, you can have it here. And these opcodes as well, they will be translated into a code. Not only they are not in assembly, they are not just they are not just like that, but they have a number, an hexadecimal value assigned to each one of those. Then you have different sections for the binary. You can see all the section, and you can of course I'm doing it on IDA, but that's again I have to make a remark that everything that I do here, you can do exactly the same from the different menus and different perspectives. If in the case of using a graphical interface, or choose a terminal, but you will get to the same result. In this action that I'm doing is basically just trying to see the segments that comprehend this binary. In the case of the binary, we have text, data, air data, frame, BSS, eData, CRT, and TLS. Okay, let me see if I can choose mute. Second, guys. All right, I think it's fine now. So please keep yourself mute so we can choose photo. Alrighty then. If you have a question, please unmute yourself and just ask as well. All right. One more thing we can do here. You can dump the strings, and there are different ways of dumping the strings. So here you can see there is type C, because you can say, okay, whatever is comprehended as a C type, then just show it here as a string. And then we'll have the address here listed, where you can just make the reference of the address. All right, so let's go a little bit faster here, so you guys don't go to sleep. So CTF, you did it nice. You can see there is something here. Let's just follow along. What I'm gonna do is this is choose a string that I can follow on this one as well. So surely this is the serial for it. I'm gonna double click on it. So basically when I double click, it will take me to this section. Yeah, that's what I show you, the sections here. And this section starts here. I will end on 14,700. Yeah, I can have the permissions and so on. And in the case, if the case is that I made a change or something during runtime, I can also take a snapshot of these sections. And that's quite handy when you have a program running. For example, let's say if the program is dumping some credentials or something in memory, and if you want to, you can just create either a dump of that program, or you can just export that section from that program during runtime, and then you can extract it later on offline while the program is not running. All right, so let's double click on this one, and then we can just follow the references for this specific DB. And as you can see, if we follow along, then we will see that it's coming here. And what I choose did, I choose follow along where this program starts. And as you can see, it's also called main, is the main section of it. And here we have different function names. And you will see that some of these functions, they are already assigned a name, but some of them, they are not. They are just called sub from a subroutine, stand from subroutine, and then the value of the memory address of the memory location that belongs. So if I double click on this one, then you will see that it takes me here, so where this subroutine starts. And then you will see that they will always start with a push of something, because they will have to push the values that came from it. If you don't understand why do they start with a push, or how a call works, remember, you can always go online and understand and read. There are way too many documents and manuals for that. All right, so we go back to it. So this is the main function. And you will see that it's doing something, and then instead of it, because this is track me, it will check, it will ask for an input, and then it will compare your input against the value. And if the value is correct, then it will just pop up a message or not. And as you can imagine, this will be the value itself. And I don't think we need to run it. Let's open the other one. All right. Now that we have understood a little bit more on how I program the segments and how they work, how a program works, I'm going to show you two things here is the compilation of the code and how to do some reversing and what is the process of doing reversing. When you did the reversing of our program, that's why we are doing on correctness first, because they are quite small and easier to understand, and we know already what is the objective, because in most of the cases it's just asking for a serial or a password and then doing some magic, and then at the end of it giving you a yes or no answer from your input, right, based on your input. So in this case, the program will start here. We can check where the program starts by looking at the exports, because always a program, if the program is to run, it needs to have a main entry exposed. And if you follow along, you will see where the program starts, right? So if you start jumping into the sections, you will end up into the real main. So this is where it starts, and then you can choose go, and at the end of it, you will end up on the main, that is this one. Yeah, and we already have it listed here, and in this case, Ada already applied some logic and understood that this is the main function, but this is the start of the main entry, and this is the main function of the program. That's two different things. All right, knowing that, then we can see that this program is going to ask for a key here. Yeah, and then we can see that is written using C++. Why do we know that? Because we already can see that it's using count, yeah, and it's using cin. So this is for is similar. This is a function similar to printf, and this is a function similar to standard, calling the standard input, right? And then from it, it's gonna make this call to establish a basic stream, input stream. So you can see it here, it says eStream. And then from this input stream, it's gonna move those values. And actually, if we enable the auto comments, we can see it. It's gonna load the effective addresses, the address of your input into, and it's gonna move it into RCX. And then from it, the buffer that now, because it's not running, it's nothing, it's also gonna move it into here. First it's gonna load the address, and then it's gonna move it, and then this one is gonna all do the same but for RDE, and then it's gonna compare those two operands. Then based on that value, it's gonna check it, and if in the case that is correct, then it's gonna come here, key is correct, and then if not, it's gonna go there. And as you can see, the flow of this program, when it's running, it will go here. You can see it has some arrows. It's gonna go here if the key is not correct. And then based off this jump, if the jump is 0, then it's gonna go here. Yeah. So in the case that here again, if the jump is 0 or not, then it's gonna go here or not, and then basically the program will end or with a successful end, or it's gonna just pop up the message saying that it's not correct. And as you can see here is actually using the output stream and then showing the message here. You can see it here. So it's, and then making the call to show the message. In the case that I'm using IDA to read the code in assembly, sorry. But if you want, you can also do exactly the same with Ghidra, and then you can also, in the case of Ghidra, you can also decompile the code. I'm going to show you the decompilation of the code, and then that is it's going to decompile this code in assembly into a pseudo C code, and then we're going to start trying to understand a little bit better the program itself. So you can see, so it's the same logic, but in this case, it's giving me a pseudo C code. Yeah, basically it's assigned. You can see that, of course, if you have the source code, and this is something that you can do if you want to understand how an application works. It's quite good. It's quite a good exercise that you write your own C or C++ program, and then you compile that code, compile it statically, and then try to decompile that code. Yeah, so you can see how it looks decompiled, but having the source code, of course, and make it just really simple. Just asking for an input, comparing the input, just like this program. That's what I'm doing it. And I was quite lazy because I could choose, instead of just using a CrackMe, I could just write a program in C and then choose and compile it. But it's still the same concept. Basically, if you do it, then you can see what you wrote and the name of the function, the name of the variables, your constants, and so on, and your buffers. In this case, it's buffer size 2, buffer 1, and then it's gonna check for the first part of the buffer, and it's gonna check for the key, and then compare the key on the string where where the key should be. And as you can see, it looks like this is gonna be your key, yeah, and then it's gonna compare it against B3, yeah. So, and this looks like it's gonna be the key, and that's gonna be doing the mem comparison. If you want to look at the mem compare, then you can choose follow mem compare here. Then you can obtain the values from it directly. So you don't have to do this. You can choose intercept mem compare and look for those values. So let's maybe we can choose run this program so I can show you a little bit more of it, and then we go into a real program that's the Java decompiler that is also quite small. Yes, we need to run it here. So because it's a Windows program, I need to be running the IDA Pro server. So it's gonna be running here. And then from here, I'm gonna run it remotely. Mouse Windows debugger. Right. Let's give you 1 second. There you go. Is it it? 131. Nope, that's not it. So it says that couldn't find it, so it's choose copying it into the target machine. So choose the VMware that I'm using for it. And as you can see, I'm running it. So in this case, what you see in red is a breakpoint, a software breakpoint that I choose to use. So I use this software breakpoint so it stops the execution of this program when it's started to run, and then based on it, I will choose following along. And there are different ways of running this program. I choose continue the execution until the next endpoint, continue the execution until the end of that call, continue the execution by one by one, or get into the functions. For example, let's make that example. So I will continue the execution from here to the next one, or we can choose do it to here. Well, we need to get an input. So let's give an input. So let's give this. What's the key? Let's say that's the key. And then it came to mem copy. Yeah. We're gonna arriving to key is correct. And something that is quite useful in the case that because you are reversing the program. So it's not every debugger allows you to do this, but this is quite useful. It's a nice trick to do. So basically set, you don't want to go to key is not correct, but you want to go into this one. So you can just mark it in green. So you know when you want to do in Jira, you can do the same. And in this case, there is no names, but you can also assign names to this, for example, to this address. This is the correct key. Correct key, and then we can also give a name to this one. Oops. Fail key. So it will be easier to understand. You can see it there. So we arrived into correct location. We want to see what goes and what is being sent into memcopy. We know that it's gonna the key is already correct, but let's just go there. So if I press F7, what's gonna happen is it's gonna take me to the champ, and it's taking me into the champ because this is a dynamic champ. So I press F8, and you can see it took the champ to the function memcopy. And as you can see here, I'm not any longer into the text section of the program. I'm into BC runtime 130.dll. So I'm into in the section of DLL in this specific location, and just running this specific function. You can see the modules that are loaded here. You can see the modules that are loaded here. And in the case, if you want to look for some specific modules, for example, kernel 32, NTDLL, you can double click on those DLLs like that. And then you can see all these modules, and you can also look for I am just checking for one protection. For example, is the debugger present? So if, let's say, this program, it will check for if the debugger is present, then I can choose double click on it from kernel 32. And if I can choose add a breakpoint, and in the case that if the program at some stage or any point will call this, will try to run this code from kernel32.dll, it will stop the execution into my breakpoint. So that's a good way. There is also an exploit pack I have added into the utilities tab. There is a memory protection scripts that they will also check for every protection in IDA. In the case that not every, but almost all of them. So I will create breakpoints. Only is doing it using a script that I made. I think it was on Python. All right, so that's how modules work. And of course, you can do the same. Let's say you try to inject something into your from a DLL, or you are just writing an exploit that injects something from a DLL. Then you can also follow and debug your code using a debugger. And just by when the module is loaded, let's say you wrote a DLL injection at some point, but you wanted to make that an exploit, and then the exploit is part of that DLL, then you can just follow along and debug that code using a debugger. So let's go back to it. So here is gonna continue the execution. And then if I press F9, if you don't know where it's gonna go, in the case of using IDA, I can choose press ESC and go back. And then something that I can do, for example, if you want to stay until the end of this function, I can choose press S9 and then continue until my next breakpoint here. There is something you can do in most of the, I think all, or not most of, but all debuggers, they allow to choose, let's choose print the message there, and you can see the message key is correct, but there is something that you can do in all the debuggers is to change the instruction pointer and assign it to something else. So in the case that you want to loop back to it, then you can. So application should exited. So if you want to look back, let's say I'm running it and now it's asking for the key again. So it will read, it will take my next breakpoint, but it's not reaching it because remember the key needs to be correct to reach that breakpoint. But I can choose go here at a breakpoint there and don't do the, I'm not gonna do the correct key. And if you want to change the flow of the program, just running it, and I think it's waiting for the key. So let's do that. Yes. Now it's gonna run, and now we're gonna give a bad key. But now you see that it's going into the fail key function. So I don't want to go there. So one way is cracking this program. So I'm checking if the sham is not zero, so I can change the flag. And to change the flag, you can choose go into setf here. So here are the flags, and here are the registers. So I will just change this one to 1. And then as soon as I change it, it stopped blinking because now it's gonna go into here. You see, I continue the execution and I made the program go there. There is another way you can use if you want to patch this program. You can make a breakpoint, and then from this breakpoint, you can make a condition and set the value to that, or you can patch it and then should always make a jump here or change this and check it in the other way around. Change if 0, and then it's gonna be always 0 if you use the incorrect key. But enough of this practice. Let's go into the real example. So this is an old program. It's called JAD. You might have used JAD if in any pen test exercise you were doing, or assignment, you were doing a Java decompilation. This is quite still used as a JADEX with a GUI interface for decompiling. You can of course decompile Java, but nowadays in security is being used as a Java decompiler for Android binaries and so on, because they still they use Java, and JADEX makes use of JAD. That stands for Java decompiler. So if we run JAD, you will see, and you can get JAD from just go JAD download, then just go into any website and then just download it. And I think I use this site. Yes, I use this site. And then just get the Linux static link, but if you can do it the same for Windows, of course. And it's a terminal. It has a terminal interface. So when you type JAD and give no command, it will give you choose the help. So like that. Or you can ask for, I think, the help itself. Does it have help? No, it should. When you type anything to JAD, it will ask for the input, and you can set the options like this. So all these options, and then the file name that you want to decompile. Of course, the file name needs to be a Java something that you want to decompile, of course, because that's the intention of using Java. You see, it's quite old and it's not maintained, and that's why it's prone. It's how many years? 22 years old. So it's prone to choose a basic static buffer overflow on the argument, and I think there are more issues with it. But of course, on the argument, if you choose to Python. You can see that it gives a segmentation fault core dumped. So yes, so you got a buffer overflow there. So let's tackle it from a reverse engineering perspective. So here you can see I'm also seeing the same values that I just showed you on the console. Here we see this copyright as part of the help. Copyright here. And see here we can see some options, the chat options, and some messages that will be triggered once you start using the options. And then we can also check for the sections that this program has. So if you are interested, you can look for those sections and you can compare those sections with what happens during runtime. There is nothing packed on this program. And here we have the subroutines. So it's a lot of them. And most of them, they were not named. But you can see some of them were, but most of them, they are not. The exports, init program, terminate program, and then the start. And then we know he has an issue, right? So how can we look for that? So when we run this program, let me show you here. And then we're gonna start the process, yes. But we're gonna give the process some options. We're gonna give some parameters. And for that, we're gonna use the same the amount of A's that we sent to it. And now if we run it, we see that we also get the segmentation violation, that because it's just an old buffer overflow, and it's trying to be run from 41, 41, 41, 41, that stands for capital A in this case. And then when you press OK, you will see here under the stack view that is filled completely with A's. And then after that, the stacks just continues. Yeah, as it was. So we need to find where this program has crashed. So there are different ways. We're gonna take the most simple one, that it just basically follow the whole program, so you can understand. I mean, it will take 5-10 minutes. That's the rest of the time we have. But we just gonna do it. There are some other ways, easier ways. We're gonna I think I can show you next time. But I'm just gonna show you how to follow along this program if we were just doing in a completely basic way. There are some other ways, like doing the backtrace, just dumping something into memory, and then trying to find that in memory, trying to find where the share registers were found, trying to get a dump of where in the memory crashed, and then or just going backward. With IDA, you can just go backwards after you crash, and then you can see where exactly the crash was. But I'm gonna just go one by one, like if I don't know how the program works, so I can just follow along the program. and try to understand how it ended up into that function. So what we are trying to do here is to find the function that is breaking the program. From a reverse engineering perspective, and also if you are trying to do it from a code perspective, because you want to fix that code, you know where has crashed, but you know it crashed. Again, guys, do not do it this way. Choose get a dump, look for the backtrace, and then choose find it where, right? Otherwise, it's a bit crazy. But let's run it. So let's do it. So we will have to run this program several times to do it this way. But I will recommend you that we have in Explorer Pack, we do have some exercises that you can do. You can compile, and then you can do it this way because it will take way less time if you want to choose doing one by one, like I'm doing here. So by choose pressing F8, and then we know it choose crash. So we're gonna choose assign breakpoint, remove this one, and then choose follow along. Then we ended up here, and again, if I choose continue F8, it will choose crash. But next time I'm not gonna do it. I'm gonna go one by one. So I will press F7, remove the breakpoint, press F7 inside. I'm gonna continue, and then it crash here on this subroutine. I'm gonna do it a little bit faster so it doesn't take forever. So press, go, stop the program, continue, remove, go inside, continue, crash it on this subroutine, go back. F9, remove this one, go to the next one, F7, go inside, continue. So I'm always playing with two breakpoints. So one to stop, one that's gonna be the one that actually breaks. So here I ended up in a loop. So this is the loop. I'm gonna check how is it looping. So from here it's going there. So from there it's going here, you see, and then from here it's going there. So at some point this jump is gonna change. You see, I'm gonna go here, there, there. So at some point it's gonna end up here. So I'm gonna add a breakpoint. Oh, not there. So here, check, and oh, I think let's go. And you go there, next breakpoint. This call, we set a breakpoint there. Continue, we need to remove this one now. Continue to the next one. This one we can remove. This was getting us out of the loop. And now we're gonna continue until the last breakpoint that is here. This is gonna go into subroutine. Again, we're gonna go inside and then continue until it crashes again. So it's on this sub. Then we're gonna stop the program, run it again, remove this breakpoint, continue execution to the next subroutine, go inside, continue, same scenario. We set a breakpoint, stop the program, start the program, remove this breakpoint, go into the next breakpoint, reach the breakpoint, get inside the function, continue execution until it crashes again. So it crashes on this call to this subroutine, breakpoint, we set a breakpoint, stop the program, continue execution, start execution, remove the breakpoint, continue execution until the breakpoint we set, go inside, and then again we continue with F8 until it reaches the subroutine, crash it, stop the program, run, remove the breakpoint, continue the execution, get inside, continue again, and then we are here. We set a breakpoint, stop, remove breakpoint, continue execution, go inside. Set breakpoint, stop execution, start execution, remove breakpoint, continue execution, go inside. Again. And I guess, as I said, don't do it this way. It's not the smartest way. I'm just showing you how it can be done if you have enough time. You shouldn't do it this way. I just follow the whole flow of the program, and I reach it the function that the function in this case, this is the subroutine that when it ends, and if you don't understand why when it ends, it just gave me the 41, 41, 41, 41, and why it tried to go there. Read online, buffer overflows, how do they work, the basic, and we do have a manual on basic buffer overflows and how do they work. It's on ExploitPack website. So now we reach the offending function. So we know it's this one. Instead of setting the other breakpoints, we can set a breakpoint on the start of the function, because now we know this is the function that is crashing the program. So we remove the last breakpoint, and then we reach the function that is gonna crash. So here we're gonna change the name of the subroutine, so we can change it to offending or buffer overflow crash function, and then we have it here. So when it is listed here, we will also see it. That's the name that we assign it to, right? We assign this name to this function, so it's easier to find. If we look at the breakpoint list, we also have this one, the first one, assign it and is enabled, assign it to this function. So if we continue, if we start the execution again with our A's, then we can actually see how our A's are moved into here, and how these are here, how do they come, and we can choose follow along. You will see it at the end of it. Open the values, pushing, and he's pushing some values into the stack. It's a Java class file read exception. So as you can see, the problem here is that when you do this, so when you run this file, and you type hello as an input, it will give you this Java class file read exception can open input file hello. But this input, the name, is taken from the stack. So this is assigned to a buffer, and then when the program is creating this error message and is taking this value from the stack to show it as I think it's doing a printf, we can check. And we have here the value of the message, and as you can see, the value of the message, instead of being hello, is just a humongous string, 9,000 times A, and because it's too big for the buffer that has been assigned to store the value of this and being shown into the error, then that's the reason why it crashes. So nice pushing it here. This might try to we can see it here into the output, and that's why we are seeing these A's. Now we choose show the message. So after it, this is the oh, let's run it again. This is the print, I think. So we can confirm that. So we go, and then there is nothing, and then we go there. That's the print. So we can see if we go inside this function, we can decompile the function, and it's indeed doing the print on the screen, of course. And then when it's trying to return with the humongous amount of A's, this is what is on the stack. Yeah, and the stack is here completely filled and overflowed the rest of the variables. When it's trying to go back into it, EVX is pointing into part of the stacks that has been overflowed, and it doesn't contain anymore the back pointer, a safe back pointer to return to the main program from this function, and then it crashes. Guys, with that, I think we're gonna end up this part, the first part of this training. So what you need to do during the week, I'm gonna drop on Discord some challenges that you should be able to follow. Those challenges they will be custom made, so there's no information online or anything. So you can also take it as a challenge itself. So, but they will be quite easy. But they are meant to be reverse engineered. Those challenges they don't impose any type of difficulty in terms of exploit development or finding memory corruption or something like that, like I should show you, but they are meant to be reversed from a logical point of view. That's a good preparation for the final challenges on the next session. Guys, I hope you enjoyed this training. This time is gonna be quite different because we made it public, this training, and it's gonna be the same for next week. So I hope you enjoy it. Just leave your feedback on Discord if you like it, and I will be sharing the recording with ExploitPack users. The recording it might be made online. It might be made. We might make it public on YouTube, but we need to think about that later on. So ExploitPack users, you will get the recording, and we might put it on YouTube. That's basically the statement. Guys, I hope you enjoyed. Have a good weekend, and see you next week, same time. Bye.